Okay, so we'll look at a couple of harder examples then involving tangents and normals. So find the equation of the tangent to the curve y equals 2x squared minus 4x minus 15 at minus 1 minus 9. So that's similar to the questions we've done before. And then the question goes on to say, find where the tangent crosses the y-axis and the x-axis. So let's take part A first of all and say, okay, it's equation of the tangent, so I need to differentiate. So dy by dx is 4x minus 4. At the point minus 1 minus 9, dy by dx is going to be 4 by minus 1 minus 4, so that is minus 8. So that's the gradient of our tangent at that point. We want to then find the equation of the tangent. So use y minus y1 equals m upon x minus x1. So y minus minus 9 equals minus 8 upon x minus minus 1. Multiply out our bracket. And bring our 9 then to the other side, and we get y equals minus 8x minus 17. So that's the first part of the question. Second part of the question then was find where the tangent crosses at the y-axis and crosses the x-axis. So B part 1 then, it crosses the y-axis when x equals 0. So in our equation of our tangent then, put in x equal 0, and we get that y is minus 17, so it crosses the y-axis at 0 minus 17. And then the second part was where it crosses the x-axis, and that happens when y is 0. So putting that into our equation, we get 0 equals minus 8x minus 17. So solve that equation and we get that x is minus 17 over 8. So it crosses the x-axis at the point minus 17 over 8, 0. Okay, our second one then, find the equation of the normal to the curve y equals 7 minus 4x minus x squared at 2 minus 5, and find where the normal meets the straight line 8y plus 3x equals 2. So starting with part A, again, first thing we do, differentiate and get dy by dx. So we get minus 4 minus 2x. So at the point 2 minus 5, dy by dx is going to be minus 4 minus 2 times 2. So that gives us minus 8. And remember, that's the gradient of the tangent. We're looking for the equation of the normal, so we're going to need to find the gradient of the normal. Remember, the tangent and the normal are at right angles to each other. They're perpendicular, so the gradient of the normal is an eighth. So then the equation of the normal, use y minus y1 equals m upon x minus x1. So our y coordinate is minus 5, our gradient is an eighth, and our x coordinate is 2. Multiply out the bracket. Bring our 5 over and it becomes minus 5. So that gives us minus 21 over 4. So that's the equation of the normal. So the next bit is find where the normal meets this line, 8y plus 3x equals 2. So you have simultaneous equations and you can solve them by substitution or by elimination, whatever one you would prefer. I'm going to use substitution. So where I see y, I'm going to replace it with our equation for y. So we have 8y plus 3x equals 2. So I'm going to replace the y with an 8x minus 21 over 4 plus 3x equals 2. So we've got an 8 times an 8th, which just gives us 1, with 21 over minus 21 over 4 times 8, and that gives us minus 42. So I've got 4x on this side. I'm going to bring the minus 42 across the other side, it becomes plus 42. So that's 2 plus 42, which gives you 44, which means our x value is 11. Now we'll have to find in the y coordinate, and we can put it into either of the equations. We can put it into the 8y plus 3x equals 2, or we can put it into the equation of the normal. I'm going to put it into this one here. So 8y plus 3x, so that's 3 11s, which is 33, equals 2. I'm going to bring the 33 across, so we get 2 take away 33, so that's minus 31. And then divide by 8, so we get minus 31 over 8. So our answer, the x coordinate is 11 and the y coordinate is minus 31 over 8.